Okay, so that was a sidetrack there. For radical equations, we have a similar problem. Remember, in radicals, you cannot have a negative number under a radical. So when we get our answer, we have to make sure that if we plug it in, we're not going to get a negative number there. Okay? And when we plug it in, that the answers equal each other. So we're going to have to go ahead and check that later. It's a future thing to do. But back to the plan. So our plan is to get the radical to one side and then to square both sides. So let's do that. What do I mean by get it by itself? Well, see that negative 2 there? That is not part of the radical. Okay, and if you can think of it, sometimes people run away from radical people. So the regular numbers are going to run away from the radical. Let's go ahead, add that 2 to both sides. And we get the square root of x squared plus 4 equals x plus 2. All right, now we have got the radical to one side. So, plan, square both sides. Because when we do that, it'll cancel the radical. Whoosh, whoosh. Awesome. And we're left with x squared plus 4 equals, well, what is that? Careful here. We cannot distribute the 2 in. Okay, there's a plus sign. What this means is x plus 2 times x plus 2. Okay, so be careful. That is a common mistake that happens. Make sure you write it out so you remember to multiply it out correctly. So we get x squared plus 4 equals first x squared outside plus 2x inside plus 2x again, and last plus 4. Okay, let's go ahead and simplify that left side by combining these like terms. X squared plus 4 equals x squared plus 4, x plus 4. Okay, so this is quadratic now, which means we're gonna, let's see. Let's set this equal to 0. So I'll move these guys to one side. Minus x squared, minus 4, minus 4. And we get 0 equals, oh, look at that. My quadratics canceled out. And these guys canceled out. So I'm just left with 4x. Huh. Well, now I have a linear equation. So the plan is to get x by itself. So let's get x by itself by dividing by 4, dividing by 4. 0 divided by any number is going to be 0. 0 equals x. Okay, we're almost done. We need to just check and make sure that this answer is correct. So let's go ahead and check. With radical equations, you're going to want to check. So this says take x squared, add 4 to it, subtract 2, and does that equal 0? Okay, so checking this. 0 squared plus 4 is just going to be square root of 4 minus 2. Square root of 4 minus 2, that's going to be 2 minus 2. And is 2 minus 2 0? Yep. Okay, so our answer is good. It checks out. Okay, so the time you want to check your answers is when you have that radical going on and when you've got your variables in your denominators, okay? Good times to check. Okay. And this is the last page, indeed. Okay. Ooh, we're getting onto some exciting equations here. Can I zoom in more? Yeah, okay. Fourth degree equations. What does that mean? Well, take a look. We got a degree 4 here. But this kind of equation, though it is not actually quadratic, we can solve it similarly to a quadratic equation. Okay. So with a normal quadratic equation, let's say if we had x squared plus 4x plus 4, what we do here is we know that this value times itself, so x times x gives me x squared, which is why we can do the x times x when we factor. Now if you notice here, a similar thing is happening. If I took x squared and times it to itself, what would I get? I would get x to the 4th power, which is what I have right here. So a similar thing that's happening here actually is happening with this problem as well. So let's go ahead and factor it like that. So I know that x to the 4th is the same as x squared times x squared. And then I'm going to treat it the exact same way I would when I was factoring a trinomial that was just quadratic. What are factors of 7 that when I add or subtract them, I get 6? Well, 7 plus 1, that works. So if I did 7 minus 1, I would get 6. But I want negative 6, not 6, so that one doesn't work. Let's do negative 7 plus 1. What does that equal? There's my negative 6. Okay, so that means that we have the negative 7 and the plus 1. Okay, so pretty much it has factored very similar to the way we do trinomials. So we're going to go ahead and keep using the zero factor property, which means we need to set each of our terms, or our factors, sorry, to 0 to solve. Oh, interesting. Now they're both regular mini baby quadratics. How do you solve those? Well, we have a quantity squared and no other x value anywhere. So let's use the square root property. Okay, subtract 1 from both sides. And we get x squared equals negative 1. Ooh, that was the wrong color. And square root both sides. Oh, I've run into a problem here. That's a square root of a negative number. That does not work. Okay, so that is an extraneous answer. Ooh, sorry. Wrote that wrong. Does not work. We cannot take the square root of a negative number. Okay, so extraneous. We're working with real numbers here. So let's take a look at the other one. Do we get an answer for this one? So add 7 to both sides. Okay, and then square root both sides. The square root of 7 is a positive number. So x equals plus or minus the square root of 7. And there we go. We have found an answer to our 4th degree equation. And we have no restrictions for these answers because there's nothing wrong with raising a number to the 4th power or squaring a number. Okay, so you don't need to check your answer for these ones. Let's take a look at fractional exponents. Okay, this one's a little weirder. Okay, so what we're going to do is we're going to use U substitution. Hopefully you have seen this before. Okay, so U substitution. What we do is we're going to pick one of the variables, either x to the half power or x to the 4th power, and we're going to let u equal that number. Okay, and what you do is you pick the lowest value exponent. So which one of these has the lowest number? The half or the 4th? The 4th. So we're going to let u equal x to the 4th power. Okay, so we're going to go ahead and sub that in, hence using u substitution. So in replace of the 1/4, we're going to rewrite it with a u. So minus 4u plus 3 equals 0. But we have a problem. We need to rewrite this in terms of u as well. How can we do that? Well, x to the half power, what is that? If I was to take a look at this equation and square both sides, I would get u squared equals, okay, we have power rule here, so it's going to be a half times 2. It's going to be x to the 2 over 4, which means u squared equals, well, if I simplify 2 over 4, that's a 4th, right? Yeah, that's a fourth. So a half. So x to the half, we can take that out and replace it with u squared. So there we go, u squared. Now this looks a lot better. That looks like a quadratic I'm used to solving. I have a sum quantity squared minus quantity to the first power. Okay, let's go ahead and see if we can factor this. So that's going to be u minus 3, u minus 1. Yeah, that works. Awesome. So we can go ahead and split this equal to 0, or u minus 1 equal to 0, and let's solve. Add 3 to both sides. Add 1 to both sides. Okay, you might be tempted to box your answers right now, but we have a problem. We were asked to solve for x, not for u. So how do I solve for x? Well, what did u equal? We said u equaled x to a fourth. So we're going to go ahead and resub that out. Replace this with x to a fourth. Replace that with x to a fourth. So now we have x to the fourth equals 3 and x to a fourth equals 1. We're not done solving yet. Shucks. Let's go ahead and solve this. X to the fourth equals 3, or x to the fourth equals 1. We need to get it x equals, not x to the fourth, 1/4 equals. So how do I do that? How do I solve for x? Well, if I raise both sides to the fourth power, when I use the power rule, that'll be 4 times a fourth. That'll be x to 4 over 4 equals, and then 4 over 4 is x to the 1 power, so I can solve for x. Awesome. But remember, this is an equation. I raised this side to a fourth, which means I have to do it to this side as well. And 3 to the 4th power, what is that? 3, let's do that. 3 caret 4, 81. And same thing here, let's raise both sides to the 4th power. So it means x is going to equal 1 to the 4th power, which is going to be, not 4, 1. Okay, so now with this problem, we actually do have to check our answers, because take a look at here. X to the half power. What is x to the half power? X to the half power is the same thing as the square root of x. And then what is x to the 4th power? That is the same thing as the 4th root of x. So I have to be careful and make sure that these answers are not negative, because if I plugged in a negative number, that would be a no can do. But none of them are negative, so they work. So we're good. Okay, so just make sure to check for any extraneous roots. Yep, let's just check one thing here. Yeah, okay. And the last problem, absolute values. Whew, we're running through lots of different types of equations in this. Why is it called an absolute value? Well, because we have an absolute value. So, what is the plan? As usual, it's good to have a plan. Plan, get the absolute value by itself, then split, let's switch those around. Split into positive and negative case. Okay. So first things first, let's get absolute value by itself, which means I want to get that 20 to the other side as well as the 2. So let's add 20 to both sides. So 2, absolute value 3x minus 7 equals 20. Divide both sides by 2, sorry. That simplifies into 10. and I have absolute value of 3x minus 7 equals 10. So here we are at the point where we have gotten the absolute value by itself. So the next step in the plan is to split it into the positive and negative case. So that means that when we split it, we know that the inside value here, it's either a positive value, which equals 10, or the value inside is a negative value. Okay, we have two options. Got to split it. Got the positive value, or we have the negative value. Let's go ahead and solve these. Pause the video, see if you can go ahead and solve the linear equations. Okay, add 7 to both sides. That's going to be 3x equals 17. Dividing 3 both sides. X equals 17 over 3. And it's okay to leave it in this form, unless you're asked to answer in some other form. And okay, let's go ahead and solve the other side as well. So, distribute in the negative. We get negative 3x plus 7 equals 10. Let's minus 7 from both sides. We get negative 3x equals 7, 8, 9, 10. And then divide both sides by negative 3. 3 divided by negative 3 is going to be, I'm running out of space here, x equals negative 1. Do I need to check my answer for these? Nope, we're good. Okay, there's no restriction on putting a number into an absolute value. Okay, so that is it for 1.5. That was a lot of information, but good thing it's recorded. Okay, so here we go. This is your written homework, 5 points each. These are due at the end of the week. Please email me if you have any questions.